Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. Are we alone in the universe? It's a question that has echoed in humanity's mind for as long as we've gazed at the stars. About 60 years ago, in a pioneering experiment, a young astronomer named Frank Drake pointed a radio telescope at a couple of nearby stars, listening for the faint whispers of another civilization. That project, known as OSMA, didn't hear ET, but it ignited the field of SETI, the search for extraterrestrial intelligence. Since then, we've scanned the heavens with radio ears, optical eyes, and more, looking for any sign that someone is out there trying to communicate, or perhaps inadvertently, making noise that we can detect. So far, no. Take me to your leader signal. But that doesn't mean we found nothing interesting. In fact, just recently, scientists conducting a new kind of SETI search found something very intriguing. A pair of unexplained, almost teasingly, artificial-seeming pulses of light from distant stars. They're not shouting aliens. In fact, they're saying, we're not saying it's aliens, but these signals are truly puzzling, and they hint at new phenomena we've never seen before. Let's break down what happened. A veteran scientist, someone who literally worked on NASA's Voyager missions and other projects decades ago, dedicated years of his retirement to a labor of love, building an optical SETI observatory in his backyard. Unlike traditional radio SETI, which listens for radio broadcasts, optical SETI looks for ultra-fast flashes of light. Think of them as potential laser pulses that an alien civilization might use either for communication or as a byproduct of something like propulsion. This scientist rigged up a 30-inch telescope and a custom photon detector and pointed at over 1,300 sun-like stars over several years, each for about an hour at a time, counting photons, little packets of light, with incredible time precision, on the order of millions of a second. Now, why look for pulses of light? Because one way to signal across the galaxy might be with lasers. A sufficiently powerful laser pulse could outshine a star briefly if you were in its direct path and looking with the right equipment. We on Earth have contemplated ideas like laser beacons, or using lasers to propel light sails, similar to that light sail concept we discussed earlier. Such laser propulsion systems could produce telltale optical signatures visible from afar. In fact, an initiative like Breakthrough Starshot, which aims to shoot intense lasers to send tiny probes to another star, would, if seen from a distance, look like a weird flash of light next to the sun for a few minutes. So if we might do it, perhaps someone else already is. Back to our scientist. After countless hours of staring and careful analysis, he discovered something really strange in the data from one star. The star is about 100 light years away, relatively close by galactic standards, and similar to our sun. On one particular night, the observatory recorded two rapid pulses of light, just 444 seconds apart, coming from this star's direction. Each pulse was extremely brief and identical in shape, like two quick blips. Nothing like that had been seen in all the other hours of observations. To make it more intriguing, when he dug into past records, he found that 4 years earlier, another star, also a sun-like star, had shown an almost identical pair of pulses, also separated by 4-something seconds. So, two different stars, two events, each consisting of a double blip of light separated by about 4.4 seconds. And that's it. No continuous signal, no repetition, at least not yet observed. Just these isolated pulse pairs. What could they be? Naturally, the first thing to do is attempt to rule out any mundane sources. The scientist, and indeed the team, once he published this in a peer-reviewed journal, Acta Astronautica, went through a checklist. Could it be an airplane flashing its lights or reflecting something? Unlikely, given the precise timing and the setup. Plus, he cross-checked against known satellite aircraft paths. Could it be some kind of glitch in the instrument? Possibly, but it hasn't shown up in thousands of hours of other data. Lightning? Meteor? Nistung? Meteor? Those usually have distinguishing characteristics, and again, wouldn't repeat exactly 4.4 seconds apart from the same spot. Some have even considered cosmic phenomena. Maybe an unknown type of stellar flare or two asteroids passing in front of the star. But two identical pulses that short, we're talking milliseconds or faster, is hard to produce naturally. Here's where the cautious excitement comes in. The phrase, not saying it's aliens, but has become a bit of a meme. But it honestly applies here. On one hand, this could be something non-intelligent. Perhaps a new natural phenomenon we just haven't seen before. Like some exotic interaction in the star's atmosphere, or a weird gravitational lensing effect causing a flash. On the other hand, the signals have some properties you might expect if they were artificial. The identical nature of the two pulses and the specific spacing could, for example, be like a binary hello, on-off in a pattern. We humans might do something like send a double pulse as a simple attention getter. In Morse code, think of it like dot, dot. Or it could be the result of some alien technology's operation that incidentally throws off pulses of light at regular intervals. Imagine, say, a spacecraft using a laser for communication or propulsion, and we just happened to catch two pulses of it. The important thing is, nobody is jumping to conclusions. The scientist himself, after exhaustive testing, titled his report something along the lines of, "We found unexplained optical pulses." Without claiming they're ET, the community is intrigued, but very cautious, as they should be. Remember the famous "wow" signal in radio SETI from 1977. It was a strong radio signal once detected from space that to this day hasn't been fully explained, but never repeated. It remains a tantalizing maybe, but we couldn't confirm it. These optical pulses are a similar case. They might be one of those one-off curiosities that we can follow up on easily. However, now that they've been found, you can bet other observatories will try to re-observe those stars or others to see if more pulses occur. One very interesting twist. The search method used was to stare at one star continuously for an hour, rather than scanning across many quickly. This is important because some signals might be so brief you'd miss them if you weren't looking at the right time. Most surveys that look for things in space can't watch a single target for that long. There's too many places to look. But this dedicated approach paid off by catching something in the act. It also highlights the idea that if an advanced civilization wanted to be noticed, they might choose a simple, obvious kind of signal like a double flash, as opposed to a continuous beacon, which would be energy intensive to maintain constantly. Which would be energy intensive to maintain constantly. A short, bright double pulse repeated. Maybe once in a long while could be a deliberate strategy. Anyone with a photodetector would know it's not random natural noise if they saw it, but it's cheap to send from the sender's side. Alternatively, if it's not intended as communication, maybe we're eavesdropping on some technology. For instance, consider those light sail concepts. If an alien starshot-like project is pushing a spacecraft with lasers, as the craft moves, you on Earth might see two flashes. If the beam swept past us twice due to some oscillation or mirror adjustment. Now, beyond aliens, let's assume for a moment it's not, because extraordinary claims require extraordinary evidence, and this is intriguing but not proof. What natural things could possibly do this? Some speculated, could it be something like a distant, undiscovered type of pulsar? Though pulsars usually flash regularly many times, not just twice. Or maybe an orbiting system where two big chunks of material glint the star's light toward us in quick succession. Imagine like two mirror flashes. But to be identical and so brief is tricky. Stars can have pulsations, but those are generally slower and periodic, not just two blips and done. Whatever it is, it's new to us, and that's exciting in itself. Or exciting in itself. It reminds me of how fast radio bursts, FRBs, were a mystery when first discovered. These millisecond radio flashes from other galaxies. At first, some even joked they could be alien in origin because they were so weird. Now we've found hundreds of FRBs and identified natural causes, like magnetars. Perhaps these optical pulses could be an analogous phenomenon waiting to be understood. Maybe something like an optical fast burst from some stellar source. One angle the scientists considered. He looked for known human-made sources. Airplanes were ruled out. Satellites can sometimes reflect sunlight in quick glints, called iridium flares, though that's radio frequencies usually. But the pattern didn't match any known satellite or space junk either. And the telescope's field of view is quite narrow, focused just on the star, which lessens the chance something else coincidentally lined up. Plus, the fact that two different stars on different dates showed a similar double flash pattern suggests it's not a one-off hardware glitch. Unless by wild coincidence the hardware hiccuped in the same pattern years apart, which is unlikely. This finding was published in a reputable journal and has undergone peer review, meaning other experts looked at it and agreed it's worth noting, and couldn't find an obvious flaw or explanation. It has definitely piqued the interest of SETI researchers. In fact, organizations running big telescopes might try to verify or refute it by doing their own optical SETI observations of those stars. If, say, in the next year someone catches a repeat from either star, or from another star with similar characteristics, then things get even more interesting. If they catch nothing, it remains an enigma. Let's entertain the alien hypothesis a bit, because it's fun and it stirs the imagination as long as we label it speculative. If another civilization were trying to get attention, a logical thing might be to send a simple pattern of pulses at target stars they think might have light. Maybe a pair of pulses is like a universal ping. Perhaps they send that every so often in many directions, hoping someone sees it. If these two events are indeed that, one wonders, why only once in several years per star? Maybe it's a beacon that cycles through many targets. Or maybe it was triggered by noticing Earth's own signs of life, like our TV radio signals, which have reached about 100 light years, the distance of one of the stars. Could it be a response? That is highly speculative and unlikely, but it's a plot worthy of a sci-fi story. Earth's early radio leakage, or our radar pings or atomic tests, etc., were noticed by a nearby intelligence, and decades later they answer with a polite double knock on the door. Again, pure speculation. But this is the kind of thing that tickles the minds of SETI scientists late at night. Speculation aside, what's wonderful about this discovery is the sense of mystery. It's a reminder that even in 2025, with so much advanced astronomy, the universe can still throw us curveballs. It could be aliens. It could be a new astrophysical phenomenon. Either outcome would be profound. If it's aliens, the long shot, well, that'd be one of the biggest discoveries in human history. If it's a natural phenomenon, that's still big news in astrophysics, because it means we have more to learn about how stars or their environments behave. But for now, the prudent path is to investigate further and keep an open mind, but grounded expectations. It's like detecting a faint whisper in a forest. You don't immediately conclude it's a mythical creature, but you also don't ignore it. You try to find its source. The story also highlights the ingenuity and passion of researchers. Here's a scientist who basically set up his own telescope system and took on a high-risk, high-reward experiment in his spare time, and found something that big observatories hadn't. That's inspiring. It shows that individual curiosity and perseverance can still make meaningful contributions to science, even in an era of huge collaborations and billion-dollar instruments. What comes next? The paper is out, so other scientists know about it. I suspect optical SETI will get a boost. More people might point their detectors at these kinds of stars, or upgrade systems to catch superfast pulses. We might also see cross-checking. For example, if an optical pulse happens, could we detect any radio or other signal coincident? Perhaps future searches will employ simultaneous listening at multiple wavelengths to cover all bases. This finding will also encourage us to think outside the box about what forms a technosignature. A sign of alien technology might take. We often think of narrowband radio signals or continuous lasers. This suggests looking for very brief sporadic signals too. In the grand tapestry of the search for cosmic company, these pulses are a single tantalizing thread. They're not enough to declare, "We found it," but they're enough to spark curiosity and renewed effort. And that's how discoveries happen. Even if they turn out to be natural, we will have learned something new and honed our techniques for the next mysterious signal. So, bottom line, unexplained does not equal alien, but unexplained is exciting. It means there's something we don't understand out there. And as Carl Sagan said, exploration is in our nature. We began as wanderers, and we are wanderers still. Our instruments are our ships now, wandering the sea of stars for odd beacons and cosmic clues. This time, they picked up a strange flicker. What it means remains to be seen, but it certainly fuels the imagination. Imagine if one day we do pinpoint an artificial origin. How incredible and paradigm-shifting that would be. Or imagine we find dozens of these signals and trace them to an exotic new class of astrophysical events, almost as good in terms of advancing knowledge. Either way, we win by investigating. For now, we have these two enigmatic pulses as a reminder that the universe still holds surprises. It's almost poetic. A blink of starlight, two heartbeats of a star, possibly saying hello or just doing something we've never seen. It leaves us with wonder. Was that a cosmic coincidence of nature, or deliberate wink from a distant intelligence? At this point, we can't say, but we can sure keep watching and keep listening. And as we do, it's hard not to let your mind wander a bit. If it were someone saying hello, what would we say back? And are we ready for that conversation? Until we know, the best we can do is stay curious, keep exploring, and enjoy the thrill of the cosmic mystery. After all, isn't the pursuit of the unknown what makes exploration so exciting? What do you think those pulses were? A new natural marvel? Or could they be something truly out of this world? The fun lies in the fact that we get to find out together.